Okay, good morning and welcome everyone to Deep Inside of Azure SQL High Availability. Uh, the term Azure SQL here, just so you're not confused, is a marketing term for Microsoft that encompasses both Azure SQL Database, Managed Instance, and SQL Server potentially running on Azure VMs or on-prem. We're going to spend a lot of time in this session talking about the ins and outs of on-prem availability groups. I'm also going to talk about how Microsoft does high availability and disaster recovery within Azure and how it's a little bit different, but a lot of the functional concepts are the same. We're going to cover some topics like troubleshooting, which I'm kind of doing right now because I blew up my AG this morning and trying to make something more impressive happen. But we'll talk about other topics like quorum, the importance of leader election, and a lot of stuff you don't really need to know to like work on an availability group, but it really helps to have some fundamental understanding of what's going on. How many of you currently manage availability groups now? Okay, for those of you who are online, that is most of the room. How many of you get frustrated trying to troubleshoot availability groups from time to time? About 3/4 of the room. I've been working with this technology pretty much since before it came out, and it's not necessarily intuitive. Availability groups are at a really complex intersection of networking, clustering, and database functionality. We'll talk a little bit about all of those in this talk. But if we think about it, with our foundation is Windows Server failover clustering, or if anybody's on Linux, and God help you, Pacemaker. Is anybody running Pacemaker? Oh, we have one person. Wow. Does it suck? No? Okay. That's good. We've had a few customers that have tried it. There's a third-party Linux solution that's okay. That's a little bit easier to implement. In VMware actually recently released a template for Pacemaker that makes the install process a little bit less painful. But no matter what kind of clustering solution you use, you have, and it especially if you've ever worked on an open source database like MySQL or Postgres, where you kind of have to build your own clustering stack. The clustering is kind of a foundation of any sort of distributed system. And we start talking about databases that are running simultaneously. And yes, I'm applying a patch to one of mine right now. It's CU17. We have to maintain state. And as DBAs, we know a lot about state, right? Because frequently we talk about developers and how they can auto-scale and do all these super fancy things. We can't do that in databases because we have to write to the database because we need to know whose bank account got a transaction in it. Well, the cluster kind of has to do the same thing. A cluster is itself a stateful system. So a cluster has to maintain awareness. It has to avoid things like split brain. And then on top of that, we add networking because we have to send data across the network, especially with an availability group. That can potentially be over a local area network where it's going from one server to another, or a wide area network. We're not always in control of what that network looks like, but we do want to know what that topology is like and if the network's reliable. For example, if you're in a cloud, you know you're probably going to have pretty good bandwidth between regions. If you're in a cloud, and I use the term, the air quotes around cloud loosely, like we've had some customers, you might have less internet than you have at home from your server. I mean, we had a customer who was consistently, their availability group was consistently falling 30 to 40 gigabytes behind every night as they did batch processing at the end of day because their connection to Azure was really poor. Troubleshooting, all this stuff can be complex. There are a lot of moving pieces. In a larger organization, you may not even have the privileges and permissions to do the layers of troubleshooting that you need to do. So I kind of put this together to have a deep dive of what's going on to save you some headaches. And poor configurations can limit your overall throughput. And I'll talk a little bit about that as well. In the worst case, it can cause you to lose data. One of the things that I find ironic about building out a high availability solution is sometimes there's more risk to downtime from the high availability solution than there was if you just had a standalone system. That's not always the case, but if they're managed poorly, they're built on top of poor infrastructure, they don't support or don't have good support, those are the kind of problems you're going to have. So I'm Joey D'Antoni. I'm a Microsoft Data Platform MVP. I mentioned I've been working on AG since SQL 2012. I've been working with SQL Server since 7, so I'm old. I'm principal consultant at Denny Cherney Associates Consulting. I'm a VMware vExpert as well. I write a lot. You can find me on Twitter at jdanton. I blog at joeydantoni.com. If you ever have any questions, hit me up over DM. So let me describe the scenario that I did, because I did something bad. I messed with my demo this morning. We still have a functional demo, but our cluster in the DCAC Colo was running on Windows Server 2012 R2. And as an MVP, I didn't want to embarrass myself and show y'all basically almost unsupported operating systems. So about a month ago, I upgraded one of the nodes to Windows Server 2016, which is completely unsupported in the cluster, but we did it anyway to see if it worked, in-place upgrade, and it did. So I woke up, I went to bed really early last night. My sleep's been weird this week because jet lag. And I woke up at about 3 a.m. and I was like, I'm going to upgrade the other 2 nodes. So I successfully upgraded the other 2 nodes of the operating system. Nothing failed. And I was like, you know, that's running SQL 2016. There's some more DMVs I can show in 2019. Let me go ahead and do that upgrade. So I upgraded the first node. That went OK. I upgraded the third node and not the second node. That didn't go OK. And it was in a state where I couldn't actually get a SQL install to run. So I think some combination of doing the upgrade and the database upgrade really screwed something up. But we have AG node 1 and 2. So that's what we're going to be highlighting. We don't really have too many demos in place that would have required 3 nodes anyway. These are all synchronous. They're all in the same physical data center in Los Angeles. One of the other things I want to mention here, because it is an added complexity to Windows clustering versus some other types of clustering, is Active Directory. And starting with, I think, Windows Server 2016, you don't necessarily have to have Active Directory in place. I would say 99% of the SQL Server workloads I've seen run on Active Directory domain join servers. The real caveats to AD with clustering are twofold. One is that you need to ensure that your Windows cluster computer object has the right to create things in Active Directory. Otherwise, you'll never be able to create a listener. This is a messy process. You pretty much need to have a domain admin in place to grant that permission. And yes, we've asked the Windows team for a simple PowerShell commandlet that would do that, and there isn't one. It's a pain in the arse, as you would say, and you have to go through the GUI to do it, or there's some like WMI calls you can make, but there's not like grant-create computer object, because that would be too easy. And I guess we can't have nice things. So software applications are written with very little error handling on networking errors. During network outage, such applications can stall or infinitely wait for an answer packet. How many of you know what the max size of a transaction log in SQL Server is? Come on, anybody? No? 2 terabytes, yeah. Good. It is 2 terabytes. A good way to find out how big that limit is to have a really busy availability group and disconnect one of the secondary replicas. Or we've had this happen at a customer recently where like they have about 8 databases in an availability group. 9 of those databases represent about 500 gigs. The other database is 12 terabytes. We wanted to split that database off into its own availability group just for manageability. They didn't want to do it because they were smarter than us, even though they're paying us a lot of money an hour to tell them what to do. And they broke it 2 times, and we've billed them like 30 hours restoring it a couple of times. So think about your planning, but there are some challenges. Like Kerberos is always a thing, but some assumptions you might want to make. The network should be reliable. This is not a topology you want to deploy if you're not confident in your networking, because what happens is it blows up and your log on your primary continues to grow. Also, if you don't have enough bandwidth, and you may ask what's enough bandwidth, it's really hard to say, But SQL Server won't push, especially if you're compressed. And if you're in synchronous mode with an availability group, you're only going to be pushing compressed streams. About the max stream, SQL Server will, uncompressed streams. The most you're going to push is about a gig, because the engine really can't push more than that. However, if you have multiple availability group replicas, you can push a gig times X number of replicas based on the amount of network capacity you have. So you can start to push some significant network traffic. Also, you want to assume that your topology is going to be pretty stable. Also, these are all fallacies. You know, that you have a reliable network, bandwidth is infinite. I know I don't have infinite bandwidth. I wish I did. But this is a distributed system slide. You may ask, why are we talking about distributed systems at a SQL Server conference? Isn't that for Kubernetes and stuff like that? Well, if you manage an availability group, congratulations, you manage a distributed system. Multiple nodes and stuff like that. We're going to pretend this slide doesn't exist. I can't find my skip over mess. So failover clustering and availability groups. You don't have to run failover clustering to run availability groups. This was introduced in, I think, SQL 2017 when Linux came in. You have the ability to use a read-only availability group. There's kind of some flaws with read-only availability groups. You can't fail them over. They're not supported for HA and DR. You can't have a listener in them. So if you only need read scale, it's a good way to do it. If you only need read scale, however, I'd think about transactional replication. It's a lot simpler topology, less moving parts to break. But most SQL Server availability group architectures are built on top of Windows Server failover clustering. I hope for those of you who support this, you're on Windows Server 2012 R2 or later. Those are the supported versions of Windows, and there are a lot of benefits. So there's a complex relationship between failover clustering and availability groups. SQL Server plays an active role in the cluster lead mechanism as to who the leader is of the cluster. And hang on, my slides aren't in sync because Dropbox didn't sync properly. My apologies. I'm missing a slide I wanted to talk about. Minor on-stage edit, just mind me. See, the setup I have up here, because of the way the projectors are working, is also a distributed system, and you can see some of the inherent complexity of getting your files to sync. So, one of the things that's really challenging in distributed systems is leader election. Just ask me about leader election. I live in America. Oh, come on. Yeah. Anyway, but the difference is, with clustering, majorities always win. Oh, come on, that should have drawn a laugh. So clusters have leader election, and it depends on the nature of the kind of clustering you're doing. This is a really kind of fundamental concept in computer science. With databases and with clustering in general, we want to avoid what's known as split brain, where half of the cluster gets disconnected from the other half and tries to start services on both sides, and you end up with mismatched data. There's a whole lot of really academic theory around this, but a typical distributed application has many tasks that are acting in a coordinated manner. They could all be instances running the same code or sharing resources. But what leader election does is allows us to decide who's the primary and how that should work. The way we do this in Windows Server failover clustering is with Quorum. Here we have node majority, which I don't think I've ever used. But the way node majority works is if we have a 2-node cluster, we lose one node. we have our cluster is now sad and down. And it depends on the version of Windows you're on, and I'm going to talk about that on the next slide, and how you lost that node. But we're going to assume that somebody pulled the plug on that server. You then lose the node. Node majority can work when you have 3 or more nodes, 3 or more odd numbers of nodes, because the odd number will prevent you from getting hit that way. However, what we typically prefer is having a third vote. If you have a 2-node cluster, you want 3 votes. Here, this is a slide that dates back to one of my first presentations on failover cluster instances in 2012, and it kind of shows a quorum disk, which is what we used to use in failover clustering back when we used SANs and stuff. I know we still use SANs, but this is more commonly going to be either a file share or a file and blob storage. But now, since we have 3 votes, since we lost 1 node, the cluster can still sustain node failure. So everything, if we have it turned to automatic, is going to fail over to node 2, and we'll stay online. With Quorum Management, dynamic quorum is now the default when creating the cluster. I got yelled at by a PM at Microsoft for turning this off in a training class, because I wanted the students to have to recover from failed quorum, but it's really pretty hard to completely lose quorum now. Another scenario that people use frequently, if you have a DR node in your cluster, you may take away its quorum vote, or like just a reporting node, because it's at a separate site or a separate location. My recommendation, if you're on a newer version of SQL Server and your newer version of Windows, and you want to do DR like that, use distributed availability groups, because then you have a cluster at each location, and it's a little bit smarter. If you're not familiar with distributed availability groups, hit me up after. I'm not going to cover it too much today, but what distributed availability groups do is allow you to have a cluster here, and then SQL manages the transport between them. So with dynamic quorum, here I have kind of a metro area thing. So Washington and Philadelphia are about 90 miles, 150 kilometers apart, and we have a quorum file share. If I lose the file share, it simply loses its vote. Then if I lose my Philadelphia node, I know it kind of went shadow, or it gets elevated. I did that poorly. It gets elevated to a voting member of the cluster. And we can take that all the way down to 1 node. So where this dynamic quorum model was really designed for was Hyper-V clusters, where you would have like up to 64 nodes. So you could kind of patch in an official way. But for the most part, most of the clusters I work on now, the customers are simply using cloud witness amongst their 3 nodes. All right, we're back to where we were. Each node in a cluster has a relationship with the AG. This is really kind of complex. The way SQL Server failover cluster instances, old school clustering, work, the service had a direct relationship with the cluster. The cluster managed the service. Here, in an AG, SQL Server has like a loosely coupled relationship with the cluster. SQL Server itself interacts with the cluster. You, as the administrator, do not, other than to view logs and things like that. So SQL Server is kind of constantly communicating with the cluster. And we're going to show that in a second. And it's called a lease mechanism. So much like you would lease a car, SQL Server renews a lease with the cluster. The difference is you might lease a car every 3 or 4 years. SQL Server renews its lease with the cluster every 3 or 4 seconds, constantly. Has anybody ever had a lease timeout? A few of you. About half the room. Wow, that's not surprising. So this is one of the kind of major faults of availability groups. SQL Server is a pretty busy application. It will happily consume all of the resources on a server. And all the wonderful developers we work with try their damnedest to make it consume all the resources on a server. And when I say resources, I mean everything. So I mean network, CPU, memory. Any of those things, if they're fully maxed out, or even storage capacity, can prevent RHS.exe, which is the mechanism that gets the lease from the cluster, from being able to get the lease to the cluster. And then effectively, your node just kind of goes out to lunch, and the cluster is like, I don't think this node's valid. Its lease expired. I had a really long struggle with this with a customer, and there are a couple of cluster lease timeout settings you can adjust in the cluster to get here. But if you really have a physical hardware constraint, it's not going to help you. Like my customer was on some pretty beefy hardware. They had 32 core boxes with 68 gig of RAM. However, what we didn't know is they had 1 gig NICs. And they had all that really fast storage and all that CPU and all that RAM, so they could push a lot of network, and the storage was fiber channel, but so they could push a lot of traffic, but they could definitely push more than 1 gig of traffic. So the funny part was we couldn't replace those with 10 gig. We had to team the 2 1 gig NICs. Unfortunately, the amount of network traffic they had was under 2 gig, and it stopped. But if you're frequently experiencing lease timeouts, that can be a problem for you. And by the way, the next slide I'm going to talk about, this won't help you with that because I tried all of them. This is how you adjust failover in SQL Server availability groups. There's a slightly different set of failover levels for failover cluster instances. The default is on critical server error, which is, I believe, over sub 20. Orphan spin locks, write access violations. 1 is on server or service down. And on level 5, you can have it failover on a deadlock, which I've never seen anybody do. That would be an interesting decision. But typically, I see most customers never change this, and I would probably not recommend changing this. If you're familiar with the old way SQL Server used to perform health checks, which was checking at server name for is alive check, it's a little bit different with availability groups. It calls a stored procedure called SP Health Diagnostics, and there's another one called SP Server Diagnostics, which is run a little bit more frequently. And that's when you can run into your release timeout if that can't complete. So my typical troubleshooting path for availability groups, I look in the SQL Server error log on each node first. This will give you the most obvious errors that are causing problems. By the way, if your databases are ever in resolving, you're screwed. There's no getting back from that. You can usually restart the instance and that'll work, but don't try. Like if you see resolving, just reboot the box. That's your best bet, unfortunately. I actually ran into that not that long ago. I had a customer who, they have 2 nodes, 1 AG that's primary on each node. This is more for load balancing than availability. And on the second node, they had a stack dump, a pretty big stack dump that happened. One of the AGs went wonky, the other one came back online. And the way we fixed it was to just reboot the node, and it came back and everything was happy. There's an always-on health X event that gets built. It doesn't really capture a lot of the data that you would want to capture. It's pretty useless. The cluster log is what I would like to go to for deeper problems. And let's go ahead and take a look at some of this. Okay, cool. You can see my machines. Here I'm on my availability group. We have a lot of availability groups on this, but I'm going to go into management, and I am going to go into X events. And here we see we do have the always-on health availability group. And if I script session as create, we can see what it captures. So it doesn't capture a whole lot. It's capturing availability group lease expired, so you'll see that state change. Those are all good things, but they don't really give you any background. It captures a couple of errors, but this has really, really never been useful to me. However, that does not mean extended events are not. Because because availability groups were built after 2012 or after 2008, they were built with extended events in mind. So there's a lot of events in place, and we're gonna do a quick look to look at the AG lease. The downside is most of these are not really supported. So if you've ever worked with extended events, there's this debug channel. None of the debug events are documented, so you kind of have to guess and figure out what they are, which is always fun. Is there a question?
Yes. We have an all availability group configured on Azure VMs. There have been instances where one of the nodes have gone down with I/O freezes with nothing running on it. How can we prevent this?
The question was around we have an AG on Azure VMs, and they're getting I/O freezes. They have some kind of combination of Azure backup and possibly Azure Site Recovery that's causing those I/O freezes. I would work with your infrastructure team to disable that. We actually just ran into that with a customer recently. All right, so I'm going to grab a couple of events. By the way, you'll notice there are two names. There's Always On and there's HADR, which is a little frustrating because Microsoft kind of changed the name of this. And here, the product originally had a code name that could easily say a vulgarity if you typed it one letter off. So they went to Always On because the other was less palatable. So we can see from some of these events how we interact, and I'm just going to go ahead and create this, and we should start seeing the cluster interact. Yeah, so here we can see the AG renewals happening all the time. The AG is also always talking with the cluster. So it's a very chatty scenario. You don't see this, it's not much traffic unless you're really looking at it. But it's interesting to see how that happens. The other thing you should note is cluster logs. If you're not super familiar with clustering, you may think that this is the log, recent cluster events. Recent cluster events can be handy if something's broke and you just want to drill in and see what happened. It may or may not help you, but it's a good first step and it's low effort. What you need to do to get the cluster log is run PowerShell. And you have to give it a destination or it will drop into, I think, C Windows System 32. And there's also a use local time flag. Although since most of you are in GMT, local time is probably the same as the cluster log, so it doesn't matter. But for those of us who are not, also you have to be an admin PowerShell when you do that. You pretty much have to be an admin PowerShell to do anything. But that cluster log is handy, and let me go over to my other node, and we'll take a quick look because I pulled one earlier. Or maybe it's on this node. We'll find out. ctemp. No, I promise I pulled that. Oh, because I'm on the same drive. Distributed systems are hard. So the one thing I wanted to show you here, I don't really have anything particular to troubleshoot in this log, but because this is in a kind of a little bit deeper dive session, Here we can see UTC plus local time, time zone offsets 8 hours. This cluster's in Los Angeles. One of the things I wanted to show you that is kind of cool about the way Windows Server failover clustering works is it uses a mechanism called Paxos. I should zoom in so you can actually see that. Paxos is this leader election mechanism that was kind of written from my research by somebody who worked in Microsoft Research, and Microsoft has definitely enhanced it. You don't really need to know any of this, but the way the cluster communicates to make sure its state is okay is by these Paxos tags, which are based on timestamps and incremental integers that increase over time. And there is a leader in a given cluster, so if you go to failover clustering, which we have on the other node, we can see that there's a current host server there, and it's LAAG SQL Node 1, SQL AG Node 1. Not super significant, but there are some cluster operations that do have to be performed on the owner. And like, if you're ever in a situation where you're down, where Quorum is down, you do have to bring up a node that owns the cluster core resources, because that's the only node that can write to the cluster database. Kind of like your availability group, like the primary is the only node that can write. In case you're wondering why we don't have multi-write databases. So the other part of availability groups, transaction log transport. By the way, I just want to step back to that question because it brings up an important point that I want to talk about. Does anybody work for a third-party backup vendor in this room? Okay, good, because some of them pay me and I don't want them to hear this. Third-party backups that do VSS snapshots can really break availability groups. It's not any one of them. They all do the same thing. I mean, there is one that rhymes with team. That is notorious for doing it, but there are a few other ones that do it as well. And effectively what they're doing is freezing the transaction log, and it works okay as long as the snapshots are fast enough and the underlying storage is fast enough that it can complete the snapshot in like under, I think the time is like 70 milliseconds. But yeah, it can really suck. And we ran into that exact scenario in Azure at a customer last week where they were using Azure Backup and Azure Site Recovery. So they were taking like conflicting snapshots, and the transaction log was just going offline in the SQL Server error log. So be really careful if you're using third-party backup solutions and availability groups, because on a standalone server, you can the log can go away for a second, and it's usually not a big deal. But when you're in an availability group, it's a big deal for reasons that we're about to talk about. So one thing you should know too that isn't on the slide that I'll mention, log transport got completely rewritten for SQL Server 2016. So if you're on a version of SQL Server older than 2016, you're effectively out of support anyway, but I understand how the world works. But availability groups work a lot better 2016 forward. The code really hasn't changed significantly in 17 or 19, other than to allow the no cluster stuff. The data protection model used for availability groups is to read transactions from the transaction log and play them to the secondary logs. In SQL 2017 and higher, there's an option called required secondaries to commit. And what that allows you to do is have multiple synchronous secondaries where you're committing so that you can maybe have a guaranteed 3 copies of your data in place. By default, it goes to the first synchronous copy, and that's when we'll walk through the flow chart in the next slide. But as soon as it gets written to the transaction log on the secondary replica then sends an acknowledgement back to the primary and says, hey, I'm good, I got that log record, you can go ahead and write it into the database, or mark the transaction complete. In synchronous mode, which is what we're talking about, if that secondary that made that acknowledgement is, say, oh, I don't know, in America, that means I'm waiting roughly 90 milliseconds, or actually 180 milliseconds for a round trip for that acknowledgement to come back. So my transaction's not going to complete for 180 milliseconds. Therefore, you only want to use synchronous when your latency is probably under 10 to 15 milliseconds. Typically, it's going to be used in the same room. There is data protection there, so I get that. But async is what you want to use for distance. There are plenty of influences on this: network bandwidth, how fast you can write, because remember that transaction has to get written into the log or hardened into the log on the secondary. So it's got to write to the storage array. So storage performance can have an impact. Limitations of the code: SQL Server can only perform so fast. Like I said, the max you'll see is about 900 gigabytes or 900 gigabits uncompressed throughput per second. And also sunspots, because random things can happen. So here's what happens, and this is a long long process. It's a long flow chart, but I like it. On the primary, the log block goes to the log cache after you've written it. It gets flushed into the log, so it's locally hardened. These steps all happen in parallel. The transaction is then sent and communicated into a log pool, where it's captured by an HADR process. It goes over the network, sends a message to a log receive queue on the secondary. It then lands in a log cache, and it is then flushed into the log. That is at the point where it's acknowledged and the transaction is considered committed. However, we're not done at that point, because your secondary is out of sync, and this confused a lot of people sometimes. Like, I'm using my secondary for reporting, but I have transactions on my primary that aren't there. Because what has to happen is the log has to play the redo back. So even though the log has the records it needs, so like if you have to recover, your database will be in sync. The database may not live be in sync. The big change that was made for this in SQL Server 2016 was that redo process now takes place in parallel, but it only takes place in parallel for 7 databases. And as I recall, it's based on the order they were added to the availability group. So if you'll have parallel redo in 7 databases, and beyond that, yeah, question. I don't think it is. I don't remember off the top of my head, but I'm pretty confident that it's not. The question is that if you have multiple availability groups, do you get double the threads? I don't think that's the case, but I can't remember. I think there's some finite limitation. I'll try to hit me up later, and I'll try to find it. But yeah, there's no real workaround. By the way, the limit, the recommended limit for Microsoft is 100 databases and availability groups on your server, no matter how you break them up. And I know there are organizations that do more than that. I know some of those organizations also have lots of weird problems. So that's what Microsoft tested. I don't work there, but I have had long discussions with some of the PG folks. That's what they tested. You can maybe get away with more, but there are a lot of places where you start to hit internal queues and stuff, where when those numbers get larger, you run into some problems. So Azure, everything in the cloud's just magic and it just works, right? It kind of is. Let's talk about high availability and disaster recovery in Azure PaaS, and I like to refer to this as Azure Magic. So first of all, managed instance and SQL database work the same in terms of like how they do HA and DR. Let me rephrase. There are some minor differences in how a managed instance that does DR, but they're functionally the same. So high availability, the way they do it is pretty cool. So when you connect to Joey's database.database.windows.net, you're not actually connecting directly into your database server. You're hitting a control ring, and that control ring is basically a gateway that's going to pass your connection onto the actual server where your database is running. Occasionally, if you look in a DMV, you can see a server name, not always. But if you're on general purpose, the way this works is very, very similar to a failover cluster instance. Azure Storage the regular Azure storage has 3 copies of data. They don't use RAID, they use object stores. So a write isn't acknowledged till it reaches the 3rd file, which is, they're all on separate disk. And when that third read is acknowledged, that's the write being acknowledged, or write being acknowledged. The write is acknowledged back to the calling program. So what this means is you only have one compute instance if you're on general purpose, but your storage is highly available. So in the event something flakes out with your VM, they just simply spin up a new VM pointed at your storage. Your storage is all HTTP endpoints in general purpose. They're all blob stored files. So you're not actually going to, it's not like a file path. It's going to file on Azure Blob Storage. And then backups go to geo-redundant blob storage. If you're on business critical, it's a completely different architecture. You either have 3 or 4 nodes. My understanding is it's typically 3 nodes, and they'll add a 4th if they're moving you or doing upgrades or things like that. It doesn't use Windows Server failover clustering. It uses a technology known as Service Fabric that's under the underlying architecture of Azure. And it doesn't use remote storage, which is why the storage in business critical is faster. It's actually pretty cool. What they're doing, if you've been in a session on Azure VMs, you might know that there's a D drive that's local flash storage to the machine that happens to also be ephemeral. So if the machine goes away, the data goes away. When you have a coordination mechanism like this, you can use that ephemeral storage, and as long as you always have 3 copies, you know you have data protection. So that's kind of the way that works. It's all local storage, so it's all fast, but they always maintain at least 3 copies. The other kind of benefit of this is if you're using business critical, Microsoft will let you pass in application intent read only, and you can have the functional equivalent of a readable secondary on Azure. I'm trying to think if there's one other thing I wanted to say there. Oh, yeah, one other thing. The other cool thing that Microsoft does that you can't is in Azure, the way they patch SQL Server is they actually inject DLLs into the running memory space, so they don't bounce SQL Server to patch it. I interviewed, if you read one of my Redmond articles from last year, I interviewed Peter Carlin, he's a VP now, but he was one of the architects. And yeah, I knew they did that because they talked about it, but he kind of told me some of the details, and it's pretty crazy. It would be really cool if we could get that in Azure VMs at least. So distributed systems are really hard. Windows Server failover clustering, I know we had one person in the room who was happy with Pacemaker, but I think Windows Server failover cluster does a much better job at abstracting away the pain points of working on clustering solutions than a lot of the other clustering solutions I've worked on. It kind of does what it says it's going to do. It works especially well if you're in one location. So remember, if you're thinking about an availability group that's going to be in 2 geographies, think about using distributed availability groups. It does require Enterprise Edition and 2016 or higher. Availability groups are really complex code. Azure greatly simplifies this process because they have completely homogeneous infrastructure, which nobody has, that doesn't run a cloud. Oh yeah, and they own the entire network. So they basically have all the bandwidth in the world between their regions. I wanted to highlight a few references because I've learned a lot about distributed systems. Although these are mostly AG references. I would, if anybody's interested in distributed systems technologies, there's a few O'Reilly books from some of the Google folks. And I haven't uploaded the slide deck, but I'll get it uploaded to the site as soon as we're done. So this is about the availability group leash relationship with clusters, understanding how failover clusters responds from unresponsive resources. An AG latency tool that's from somebody on the CAT team, AG latency troubleshooting, and then HA for Azure PaaS. And then here's my info. If you have any questions after, email me. Hit me up on Twitter. My DMs are open. Do we have any questions from the field? Any other questions in the room? Cool. Thank you, everyone.